So quick intro from me. I'm Harry Ellis. I've been working at Digital Gravitas for over 4 years now. We also have Russell, Louis, and Harvey from our iOS team joining the call. If you don't know us, we're a market-leading specialist iOS recruitment team, and you can see from my LinkedIn page and the other people in our team's LinkedIn pages the caliber of companies we partner with. So some of them are the likes of ASOS, Bumble, and Marks and Spencer's. We also have teams specialized on Android and product recruitment. So please reach out if you have any questions on hiring, or if perhaps you or a friend might be interested in considering a new job. The market is a bit crazy at the moment. So yeah, it'd be good to hear from you. But that aside, the main reason why we wanted to organize these Mobile Digest events every couple of months is with our jobs as recruiters, we get a lot of exposure to hearing what people are talking about in the iOS community, from speaking to lots of mobile leaders and obviously candidates on a daily basis. Yeah, perhaps too much, some of you would argue. But ultimately, we really wanted to bring all of you value, create a platform and get voices heard and digest some really exciting material. So yeah, overall, really passionate about iOS. We want to see businesses doing great, and it's an exciting industry to be part of. So without further ado, I'm now pleased to introduce Tomas Ruiz-Lopez to the stage. I've had the pleasure of working with him on his journey to Good Notes, and noticed his work received lots of recognition from the iOS communities, and thought it'd be silly to not ask for him to present to us today. So yes, Tomas, I'm going to virtually pass the mic over to you now.
Thanks, Harry, and hi everyone. Good afternoon, and thank you all for coming. First of all, I would like to thank Harry and Gravitas for the organization of this event, and also for sending me an invitation to be speaking here today. So
you're very welcome.
So yeah, I'm Tomas Ruiz-Lopez. I work as a senior software engineer at the iOS team at Good Notes. You can find me on Twitter at Tomas Ruiz-Lopez. And you may also know me for my previous work in the Bow library and other related tools and libraries that you can find at bow-swift.io. And these libraries aim to bring functional programming concepts into Swift. And when I am not programming or doing something in these side projects, I enjoy playing my board game collection or reading comic books. So today I'm going to be talking about one of the two hottest topics in iOS development, or probably in the entire Apple ecosystem, which is SwiftUI. Later, Donny will be talking about Combine. So these two new frameworks have been received with a lot of enthusiasm by the community, and they aim to modernize the way in which we build applications for the Apple ecosystem. But at the same time, they pose important challenges for our teams and our companies in order to adopt them and get the most out of them. So in this talk, I will introduce what SwiftUI is, why we need it, and how we can get started with it. So probably most of us here today know already what SwiftUI is, so I will quickly introduce what it is. Also, SwiftUI is a new framework for creating our user interfaces that was announced during WWDC 2019. The initial version that we got included the most basic components, such as labels, buttons, and very simple layouts to create our applications. But this version had some limitations. Last year, during WWDC 2020, we got a new version, including much more powerful components, also important improvements in terms of performance, and a lot of bug fixes. And we could probably expect a new version of the framework within a few months when the next WWDC gets announced. So SwiftUI lets us write native code for our user interfaces for all Apple platforms. The main difference with respect to UIKit is that it proposes to follow a declarative approach. This means that we no longer have to follow the imperative approach in UIKit, where we have to give precise instructions on how to add a view to its parent and how to set up their auto layout constraints. Rather, SwiftUI proposes to have a DSL, a domain-specific language, where we can start with the smaller views and then compose them into larger ones to build our screens, and also apply modifiers to our views in order to customize their appearance. Another important difference with respect to UIKit and using the interface builder is that now SwiftUI views are written in Swift code, or you can also design them using a graphical editor. As I was saying, the main difference is that both the graphical editor and the code always remain in sync. This means that we can start designing our view in the graphical editor, and then later jump into the code and finally tweak the final details, or the other way around. We can start typing our Swift code for describing our view, and then fine-tune some parameters in the graphical editor. SwiftUI relies heavily on a lot of changes that were proposed into Swift evolution. So we can say that Swift had to change or to evolve in order to accommodate some of the features that were the main characteristics in SwiftUI. In particular, both SwiftUI and Combine make heavy usage of key paths, like for instance, in this case, to access parts of the environment, in this case, to access the color scheme. Property wrappers also let us wrap parts of our state so that we can trigger redraws of the views whenever those parts of the state change. Other proposals, like the ones listed here, namely omit return, opaque result types, function or result builders, and multiple trailing closures, have contributed towards having a much more expressive DSL that lets us describe our views with very little boilerplate code. Good, so now we know what SwiftUI is and how we came here. And we can ask ourselves, well, why do we need SwiftUI at all? Because we are doing quite okay with UIKit. Which benefits can it provide to my product or to my team over UIKit? Well, I bet most of us here today are iOS developers, and we are very used to using UIKit. But if you have ever tried to write a native macOS application, you probably have noticed that you have to use a different framework called AppKit. Although both UIKit and AppKit have some similarities, there is an important mismatch between them that may act as a barrier to develop more native macOS applications. SwiftUI aims to bridge that gap by proposing a common API for all Apple platforms for the UI. So this means that we can learn it once and just use it everywhere. Notice that usually there is a common misconception about this statement, and most likely this does not mean that we cannot use this does not mean we can use the same UI code for every platform that we are targeting. You will probably need to craft different views for the different platforms that you're targeting in order to leverage the unique characteristics of the platform that you're targeting, such as the screen size or the input method. But you can still use the same APIs for all of them. SwiftUI also aims to modernize the way in which we build applications, following this declarative approach to UI development, similar to what we are seeing in other communities, such as in web development with React Native. As for the benefits, we can say that SwiftUI is very easy to learn. If you have ever tried to write HTML code, you can see that the approach, the declarative approach, is quite similar. We can get faster iteration cycles with SwiftUI thanks to having a live preview system that it's included in Xcode, where we can render our views even in multiple configurations at a time. We can change locales, themes, or screen sizes and render our views simultaneously in all these configurations. Moreover, our views can become interactive just by launching them from this preview system, which also becomes significantly faster than launching the entire application and then navigating to the view that we want to preview. In SwiftUI, our views are a function of our state. This way we can easily track which parts of our state are rendered in which parts of the view. Also, as I mentioned before, with property wrappers, we will get automatic redraws of our views whenever we assign a new state to the properties that are wrapped with certain property wrappers proposed in SwiftUI. Similarly, when the user interacts with the user interface, we will get a state update. Like, for instance, when the user types something into a text field, or when the user flips a switch or something like that. SwiftUI favors composition over inheritance. In fact, we no longer have to subclass UI view or any other UI kit component in order to customize our own. This promotes a programming style where we can start with smaller views and then compose them to make larger ones, which makes our code much more easy to reuse. Another cool benefit that we get is that we get animations out of the box. We have said that SwiftUI will trigger redraws of our views anytime we have a state change, but it will not stop there. It will try to animate from the previous state towards the new state if there is a clear animation to do that. Moreover, these animations are cancelable and reversible. This means that if a new state change happens in the middle of an ongoing animation, SwiftUI will not have to wait for this animation to complete. Rather, it will try to animate from the midpoint we are in towards the new state. Finally, and this is one of the benefits that I like the most, is our merge conflicts are now much easier to resolve than trying to address them in a zip file or in a storyboard, as our views, as I said before, are now plain Swift code. Despite all these benefits, there are also some drawbacks. In particular, the first one is that we must target iOS 13 at least in order to be able to use it in our projects. Nonetheless, if you want to take advantage of important improvements like lazy layouts to display large amounts of data, you will need to target iOS 14, as these components were introduced in the second version of SwiftUI. And supporting iOS 14 may not be feasible for some of our projects. Another drawback is that it involves a big mindset change to adopt SwiftUI. The declarative approach forces you to rethink in the process in which you lay out your views. In fact, one of the hardest parts to understand from SwiftUI is the layout system as soon as you start building much more complex layouts than the trivial ones that you can find in the documentation. Finally, even though you may decide to deep dive into SwiftUI, you may still need to use UIKit for certain tasks, like, for instance, integrating with legacy code that you may have in your code bases, or with third-party libraries that have not yet been updated to use SwiftUI. So this brings a new question to our table. How easy it is to have both SwiftUI and UIKit living in the same project? Can I transition from one to the other? Well, fortunately, yes, we can have both at the same time coexisting in our project. And if we are writing a SwiftUI view, and then we need to incorporate a UIKit component that has not yet a representation in SwiftUI, there are some protocols that we can implement in order to make our UIKit code compatible with SwiftUI. In particular, we have UI view representable to wrap UI views, and UI view controller representable to wrap UI view controllers. If we need to go the other way around and have a SwiftUI view integrated into UIKit code, it's as easy as just creating the view and embedding it into a UI hosting controller. With this, we can carefully plan our transition from UIKit to SwiftUI, having both coexisting at the same time in our project. Good, so by now you may be sold on the benefits of using SwiftUI, but you can start wondering, well, how can I get started with this? Because my app targets an older version of iOS, so I cannot afford to start using it in production. Well, we have said that Swift has had to evolve in order to accommodate new features that are widely used in SwiftUI, but these features are not exclusive to this framework. This means that you can learn the features in different contexts. For instance, property wrappers have a wide variety of usages that you can find in other libraries, or even you can define your own. And with function or result builders, you can design better DSLs for other purposes. Another possible solution to get started with SwiftUI is to prototype new user interface ideas for your application using SwiftUI, even though you may end up ditching them and then re-implementing them in UIKit, but it's a good way to experiment. We have said that we can benefit from the preview system to get preview renderings of our views in multiple configurations at once. So this means we can get visual feedback of what we are experimenting with much faster and iterate over our ideas more quickly. Even if your application is targeting an older version of iOS, there are new APIs in the system where you can or even must use SwiftUI. That is the case of the widgets API. So this is also a good opportunity to get your hands on SwiftUI in a real-world experiment. Another cool way to get started could be to create macOS utilities for internal usage of your team. In these cases, it's easier to raise the target version of your application as we tend to use the latest version of macOS in our development devices. For instance, in previous teams I used to work with, we developed some custom Xcode extensions for our team, where the user interface was designed using SwiftUI. So that let us learn some of the features. And finally, the most straightforward way would be to build pet or sample projects to get familiar with these new components. Okay, so let's say that you come to a point where you have learned enough SwiftUI and you can afford to target a version so that you can start using it in your application. And you start wondering, what about my architecture? Can I maintain the same architecture if I am using SwiftUI? So perhaps there is a better question, and it is if you should maintain the same architecture. Whereas SwiftUI is sort of independent of your app architecture, it's true that there are certain architectural styles that align better with the ways that SwiftUI views are created. I am referring to the so-called unidirectional data flow architectures, such as Redux or the composable architecture, that may fit better for this new paradigm. In particular, we can say that SwiftUI has a deep synergy with Combine, and it's better aligned with the principles of functional reactive programming. So at this point, I'm going to hand it over to Donny, who is going to be telling you more about these topics.
All right, thank you very much, Tomas. Great introduction into SwiftUI, and also a nice segue into Combine, which is the driving force for SwiftUI. But before I talk about Combine, my name is Donny. You may have read some of my stuff online on my website, donnywals.com. My day-to-day job, I am an iOS engineer at Disney Streaming Services, and most of my free time is spent writing, doing presentations, workshops, and all that kind of stuff. Or if I'm not doing that, I'm most likely playing the guitar or listening to some music. I wrote 2 books recently last year, one on core data and one on Combine. And the Combine book mostly came to be because I was curious about Combine. I already knew a little bit of RX Swift. I wanted to see what Combine was all about because, well, it seems like it's becoming a more important part of iOS development to be into functional reactive programming. So let's dive right into the topic and ask the question, what is functional reactive programming? And of course, what is it used for? So functional reactive programming is, at its core, if you would ask somebody who's really good at it, it's all about values over time. And I remember when I was learning functional reactive programming that was quite possibly the least helpful way to explain the topic to me. And that's when I started looking into it, and I figured that the root of functional reactive programming is, of course, in functional programming. And that, of course, sounds really complicated if you're not familiar with functional programming, but some examples of, generally speaking, the knowledge you need to have is Swift's map, flat map, reduce, and all these similar functions that you know and love from arrays. Right? Except the main difference between Combine and arrays, of course, is that in Combine things can happen asynchronously and they can happen sort of at any given time, right? So the collection that you are working with or the items that you're mapping over are not delivered to you synchronously like they are in an array, which is, for map, flat map, reduce, they're almost all like sort of special versions of a for loop. And in Combine, it's more like a pipeline. And that's why in Combine, when we make a chain of operators, we tend to call these a pipeline. So to show you a little comparison, if you would look at an array of 3 items in Swift, for example, just 1, 2, and 3, you can flat map over these and you can return a new array from within your flat map. And if you print the output, you will have a single depth array, right? There will be no nested arrays. And this is all, I assume you're all sort of familiar with these ideas. Now, if we look at combine, we can immediately see that there's a few things that are different. You can still have an array. This is, of course, mostly useful for demo purposes. You don't often use this in production code, but for demoing, it's perfect. So if we have that same 1, 2, 3 array and we make it a publisher, we can still flat map over it. And you can see that the flat map body is almost identical to what the previous one was, except instead of returning an array, we return a new publisher. And what combine then does is it flattens this into a single publisher. So if you would print the output by subscribing using combine sync, you'll see that you get 1, 2, 3, etc. printed. So it's not like you're printing an array. If you don't know combine, I understand that this is a little bit confusing. And the main thing that I want you to take away from this is how similar arrays and collections in Swift are to publishers in combine. And their main difference is that a publisher will emit values as they are generated and as they become available, whereas in an array, you loop over an array synchronously. So now that you've seen this, let's go over some of Combine's most important components. Now, the input for a pipeline is always generated by a publisher. I just showed you a very simple pipeline where we have a publisher that publishes integers into a flat map, and from there we move on. Now, the receiver of the final transformed value is called a subscriber. So that was where I called sync and printed out the values that I had generated. The relationship between publishers and subscribers is encapsulated in something called a subscription. And this subscription is wrapped by a cancelable. So in the previous code, you saw that I held on to some object that I called a cancelable, and that was what that was for. Now, these components together make up all you need to know to understand Combine's basics. Of course, you can end up in very complicated situations where you have a lot of different operators that are chained together and you have a lot of work that's being done. But the basics are always the same. There's a publisher, there's a bunch of operators, and there's a subscription. So how can this improve my code? Especially if you're not familiar with Combine, it's common to wonder how and why you would want to do this. Well, the improvements that I mostly see are around asynchronous work. And if you've ever written asynchronous code in your app, you're most likely familiar with the pyramid of doom or callback hell, where you write code and you keep indenting with tabs and you end up changing your tab space to 2 instead of 4 because otherwise everything falls off the screen. And at some point, you're basically not even sure where you are in your code. And a lot of your code will be around error handling, around making sure that you call callbacks, around making new calls to the network and passing your callbacks around. And it can get really messy really quickly, especially if you have deep levels of nesting and you get these branches of logic. I'm sure you all sort of understand what I'm getting at. And by modeling this asynchronous work as a publisher, you can chain other work on top of it by using an operator. So instead of nesting and instead of going further and further off to the right-hand side of your screen, you sort of write everything down as a chain. So you can say, fetch one thing from the network, flat map over the result and fetch another thing, and flat map over the output of that and return another thing. And you don't have to keep indenting deeper. You're basically only indenting one level for your flat map all the time, and then the next operator comes after it. So it's much cleaner. And what's also very cool is that these pipelines that you create, so this publisher with these several operators applied to it, form a new object, a new publisher that you can pass around and that you can return from a function or pass to another function. So that also makes it so that you don't have to do everything in line. Like you can have a couple of operators return a publisher from a function and then apply operators on the output of that. I'll show you what I'm talking about in just a moment, because I understand that it's probably a lot to sort of mentally visualize if you're not familiar with it. Now, one note that I want to sort of call out on the part of asynchronous work is that I do think that a lot of asynchronous work will be superseded by async await in Swift, where we can sort of, instead of doing all the callbacks, we can just say like await the result of this async operation and then work from there. But I'm sure there'll still be a place for combine in this async world. Okay, so let's look at the example that I promised you. This code should look familiar to most of you. We have a function fetch feed. It takes a completion handler, makes a network call, checks whether we have data or not. If we don't have data, we should probably have an error. If we don't have an error, we have something else going on. And it's all very straightforward. And it's a lot of code. And we don't have a ton of nesting here. But you can imagine that if we would want to make a new network call based on my decoded data on line 15, that we would basically double the level of nesting and double it again if we would want to do another API call. Of course, we can extract some things into functions, but it does tend to get messy, especially considering ensuring that we call our completion handlers at the right time. Looking at this exact same functionality in Combine, it would look a little bit like this. We have function fetch feed. It returns a publisher. This publisher will either emit an error or fail with it will emit a feed or fail with a generic Swift error. We return a data task publisher for some given URL. We extract data using a key path. We decode that data into a feed, and we erase to any publisher, because if we don't do that, our return type would be something like decode map, or decode publisher, map publisher, data task publisher. They're all generic over each other, and it's all messy. So erasing to any publisher makes this a nice API. Now, what's really cool is that all the error handling here is gone. And the reason is that every one of these operators will emit its own error if needed. So the JSON decoder will just emit an error, and then the subscriber can receive that error. So we don't need to handle that ourselves, because it's just a failing publisher at that point. So you can really clean up a lot of your asynchronous code using a few simple operators in a publisher. A second example that I love about Combine is that it makes it easy to expose state changes. And if you're working on iOS, and also I think macOS is the same. I don't have a ton of macOS experience, but I'm pretty sure it's not all that different. It's common to have parts of your code respond to things that happen in other parts of your code, right? For example, if you have some view model that fetches data, the view model changes, you want to inform your view controller and reload some things. That's very common in UIKit. Another thing that's common is that we use delegates or callback closures to receive these changes. So consider a location manager, for example. A location manager takes a delegate. As soon as new locations become available, this location manager will call methods on its delegate to tell you about a new location. Now, Combine can model these state changes as subjects. And subjects are a special sort of publisher that allows you to publish values at will. So that means that if your location manager receives a new location, it could forward this new location over a subject. So let's look at an example of that. Tomas, can you go one slide further? Thank you very much. So this is an example of a very simple location manager delegate wrapper. So let's go over the code a little bit. It's a class, inherits from this object. It's a CL location manager delegate. I define two subjects here, one for the current location, one for the current authorization status. And I receive an instance of CL location manager. I do a little bit of setup, and I assign this object as a delegate for the location manager. And whenever a location manager did update locations is called, I simply update the value of my current location object. And with this, it would be possible for any other object to use an instance of this location publisher and just subscribe to the current location. And I could also do this in multiple places, of course. So I think, and I hope that Apple will sort of keep this pattern going. And I think they are, because SwiftUI lends itself really well for this, where instead of using delegates for everything, we move to a world where things are modeled as publishers rather. Okay, so now that you've seen this, where do you start using Combine? Because I've shown you a couple of examples, but of course, these are examples that work really well for me, and we're here to talk about what might work for you. So when you refactor to using Combine, the first thing I would tell anybody is not do it all at once. Instead, find some edges in your code base that produce asynchronous output. I think the network is a really good example of this, of a place where you typically sort of that sits at the edge of your architecture, and you can sort of work your way in from there instead of starting with Combine at the core of your architecture and working your way out, because that means that you're typically going to do a lot of wiring code and glue code and a lot of nasty things to make everything work. So try to find some edges. Once you've done that, look at some of your delegate relationships and see if you can write objects similar to the one that I just showed, where you have a location manager, for example, and a few subjects to subscribe to, because that, I think, is a very nice pattern to use, and it's very useful and also not that complicated to reason about when you're getting started. And once you've sort of identified these edges, like your networking layer, of course, refactor them and make sure that they use Combine as good as possible. So how does Combine relate to the UI? Because UIKit, of course, is its own framework, and we've talked about SwiftUI, but how does it relate to any other UI? Well, of course, SwiftUI was built to work really well with Combine, and it uses it extensively. You might not even think about it, but an observed object in SwiftUI is an object that uses Combine to inform the SwiftUI view or SwiftUI render engine about when the object will change, so that SwiftUI can schedule a re-rendering. And also, published properties are also used for SwiftUI, and a lot of things in SwiftUI are really built on top of that FRP principle, where something changes and your view wants to respond to it. And a lot of your Combine code, when you're writing it, can and should be UI agnostic. So the fact that SwiftUI relies so heavily on Combine does not mean that Combine relies heavily on SwiftUI. Instead, Combine simply has a beautiful interface that SwiftUI can wrap and build on top of and update beautifully. But UIKit objects can do this as well, except, of course, Apple didn't put a ton of effort into putting bindings for UIKit into Combine. So if that's something that you're interested in, I would recommend you take a look at the Combine community repository, because we'll probably add a link somewhere, because they have done a lot of work to add sort of what RxSwift does, if you're familiar with that, add nice bindings so that you can, for example, say my button tab publisher or stuff like that. This is really cool. And lastly, architecting an app that uses Combine. Now, if you are starting from scratch, MVVM is an architecture that lends itself really well for functional reactive programming. And that's mostly because MVVM already has this concept sort of where the view model will hold a lot of data and bindings for the UI. So wiring that up using functional reactive programming is a very beautiful place to try that. Also, if you start with Combine and you think to yourself, I think I need a custom publisher, you probably don't. Apple actively discourages you from writing your own publishers because publishers are not easy to write well. There's a lot of memory management that you need to do correctly. There's a lot of gotchas in how publishers work. So typically what you'll want to do is use a subject instead, because you're probably looking for some object or some publisher to send values over whenever you want to. And that's exactly what a subject is for. Also, if you find yourself applying the same stack of operations or operators on a pipeline, try to wrap them in something custom. Just make an extension on publisher, write a function, and return self.map.flatmap. Whatever you want to do. That creates a new publisher that you can return, of course, and it makes it easier to sort of reason about your code if you group related things together, just like how you would normally group related function calls together into one bigger function to prevent calling a bunch of functions in a row. And lastly, I would like to recommend that you don't try to force Combine into places where it doesn't fit. Regularly, I talk to people who try to make Combine into a task runner, for example, where they want to do one thing and then do 3 other things and then get the results from all of these things and put them into one place. You can do this in Combine, but when you try to do it, you'll feel the friction and you'll notice that Combine was not meant for this, because Combine is not a scheduler, it's not an operation queue replacement. It's just something that allows you to respond to changes in the environment over time, apply operators to it, and sort of get an output. So if you find yourself fighting Combine, look at the other tools that are available to you. Maybe you're looking for an operation queue. Maybe you're just looking for something that runs asynchronously on a dispatch queue. And with that, I would like to thank you very much for your attention. And we're going to go on into the question portion of the meetup. And I have one question for Tomas to kick things off. And that is, what do you think, Tomas, is going to be in that? You talked about SwiftUI, but I'm going to ask you a combined question because I know you are very big on functional programming. What do you think will happen with async await and some of Combine's features?
That's a very nice question. I think async await is providing support for some of the features that we have in Combine, especially whenever we have just publishers that emit a single value. I read, I think I need to read more about the proposals, but I've read also about async sequences, which is quite similar to what we could get with publishers. So in the end, it's the same thing. And if you watch my talk in NS Spain this year, if not, you can look it online. I was discussing about this specifically. Async await is more of a syntax sugar on top of chaining flat map operations, especially to reduce this noise that we were having with callback hell that you mentioned in your talk. Even though with Combine, we reduce quite a lot this callback hell problem. If we have nested flat map operations where we have a function that returns a publisher, and then based on the values that this publisher emits, we have to invoke something else that also returns a publisher and so on, we still go to that problem. We still will have the callback hell problem. So I think with async await, we will get rid of that, as the language knows the pattern that we are trying to solve. It knows that we are executing asynchronous operations that will not need to have this nesting in order to be readable. And yeah, the compiler will do pretty much all the work for us.
Yeah, I definitely agree with that. Great point also on like nesting flat maps. You can still get into that callback hell-ish situation. I think they're probably going to coexist a lot. They're probably going to find their own problems that they're solving.
Yeah, definitely. Still, we still need to get familiar and know how to get the most out of what Combine offers in order to know which cases are better suited for Combine and which cases are better suited for async await.
Yeah, for sure. So I see a cool question from Joffredo here, and he says, thanks to the both of us. Well, you're welcome, Joffredo. And he asked, with actors plus async await plus Combine, there's definitely the feel of a next generation Swift platform, similarly to when GCD was introduced, or maybe bigger. What do you think? And I definitely agree with that. I think this new suite of asynchronous programming capabilities that we're about to get is going to be huge.
Yeah, definitely. Actors and async await are like patterns that you can see in other languages, especially in functional ones, and they have proven to be very effective at tackling concurrency issues.
So, yeah. And one of the bigger problems that I solve in my work almost every day is, so I work on an SDK, and we do a lot of multi-threaded stuff, and we basically don't know how our code is going to be used exactly. So most of our crashes and problems and issues that we run into come from shared access of dictionaries and that kind of stuff. So we need to synchronize a lot of access of properties in our code, much more than you would maybe expect if you are not familiar with sort of that level of multi-threading. And actors is basically going to obsolete all of that for us, because I cannot wait to start using it and basically say, this thing is an actor and only I can access my own properties, so they'll always be synchronized. That's going to be huge. It's going to be a big improvement.
Yeah, definitely. I'm a big fan of every benefit that we can get at compile time. So if the language supports all these notions like first class, we are going to get rid of a lot of issues that we're having right now.
For sure, yeah. Any other questions from the crowd?
There's the big question, Donny and Tomas, of are these technologies production ready yet? Which I hear a lot from managers particularly. So yeah, what are your thoughts on that broad topic?
So personally, I think Combine probably is. For iOS 14, Combine basically received no update. So that's also Apple just telling us like, hey, we're happy with where this is at right now. Or they're telling us we're so unhappy with it. We tried it for a year. We're going to ditch it next year. I think it's the former. I think they're sort of happy with where it is. SwiftUI, I personally feel like it's still moving a lot, and they're going to add a lot to it every iOS version. So whether it's production ready or not really depends on, does SwiftUI support what you need in your minimum version? I don't know what your thoughts are on that, Thomas.
Yeah, I think SwiftUI version 3 is going to be like SwiftUI 3, Swift 3 was to Swift development. I think the next version will be the one that clearly sets the grounds for how to build a SwiftUI application. So still you can write, and I have seen many applications, and I have some applications in the store that only use SwiftUI. But yeah, if you're in iOS 13, you can experience some weird bugs. And yeah, even though some of them were fixed in iOS 14, still, yeah, you can expect unexpected things happening. And yeah, depending on how critical is that for your product, I would recommend you not to go too deep on that.
Yeah, I definitely think it's not like all-purpose production ready, but it is. The things that are ready are production ready. Like the good parts are really good.
Yeah, it also depends on the complexity of the layouts that you're building and so on.
Yeah. So let's see, we have a bunch of other questions. There's a SwiftUI question from Callum. Have you had much experience when dealing with SwiftUI accessibility and UI testing? We currently have a massive suite of UI tests and accessibility requirements. I do not have a ton of experience with that. Maybe you do.
Neither, but my feeling is that every time a tool gets announced, the testing part is the forgotten one. So I think they still need to offer us new tools to be able to properly test the UI. My go-to way when testing the UI is using a screenshot testing. Yeah, you can check what the guys at Point Free have been doing, because they have a library for screenshot testing, and also they have put a ton of effort into testing flows in a nice way using their architecture. So you can get some inspiration on how to tackle that problem from how they do it.
Yeah. Question for me, what do you think about replacing promise code with Combine? Does that make sense? Not really, to be honest. Combine is not a promise library. It is very similar. It has a lot of similar affordances, but if you are happy using promises, then you're probably not looking for Combine, because promises really wrap that sort of single piece of work, right? A promise doesn't live for a very long time. It doesn't produce outputs over time. It does a bunch of work and eventually will fulfill the promise. So it's a different mechanism, and it also has a couple of features that you won't find in Combine, and Combine has a lot of features that you won't find in Promise Kit. So it kind of depends on what you're trying to do, but it's definitely not like there's a very one-to-one mapping between Combine and Promise Kit. Let's see, and we have a question from Bogu. What are your recipes for organizing navigation when it comes to SwiftUI and complex multi-screen applications? Tomas.
I haven't had to deal with that yet, so I cannot provide any input on that, unfortunately. Right.
Yeah, the one thing I know is that SwiftUI is definitely, because of how it works and how state is basically modeled, or how your views are modeled on your state, it can be a little bit complicated. Like in UIKit, you have all the full control over the navigation. You can all kinds of crazy things, and that's not as easy with SwiftUI. But yeah, sorry, no huge experiences for me either. Just wondering what's your experience with navigation between screens in SwiftUI. I have seen state-based navigation like Redux, or even wrapping SwiftUI and UIKit-based navigation with UI navigation controllers and model presentations. What would be your go-to for SwiftUI navigation for a big app? From Tim. I feel like this one builds on the previous one, but it's also something that I have heard before, where people just sort of use SwiftUI for the views, but not necessarily for the view controllers, if that makes sense.
Yeah, well, in the apps that I've been trying to build, as we try to go only for SwiftUI, yeah, we only had to use UIKit and the conversion kit for things like, I think it was something like the Apple sign-in button that even though it's quite recent, it didn't have, at the moment we were implementing that application, we didn't have a SwiftUI component for that, so we had to wrap it in there. But we were trying to use the navigation based on the state. And yeah, it may be suboptimal because in the end you have mixed the state of the application plus the state of the navigation. So you have to be very careful on how to separate both things so that properties don't start messing with others and so on.
Yeah, I definitely agree with all of that. Another question from Antonio. Thank you both for your presentations. I would like to ask your thoughts about using core data with SwiftUI and Combine. For example, do you feel necessary to introduce intermediary layers, or is it easy to integrate them directly? Now, this is a very interesting question that I personally have a lot of opinions on. And you can introduce a lot of intermediary layers if you want to, but it's very easy to integrate them directly. And especially with core data, the more you try to push it into its own corner, the more you're going to find that you're fighting the framework, the more you're going to find that you're introducing friction, the more you find that you're going to run into performance problems, because core data was designed to be your model layer. So sort of making core data your storage layer instead of a model layer is going to make things complicated for you. So even though I have thoughts on the add fetch request property wrapper in SwiftUI, and I don't like having a fetch request in my view, it is the best way I have found to fetch data into your view. It performs much better than anything you can do yourself, and it's much less code than anything you can do yourself. And if Apple decides to at some point replace core data with something else, they'll probably make it so that fetch request will work with either. So that is sort of my thoughts on that. Do you have anything?
Yeah, I completely agree. I think I don't agree from a software engineering perspective. I don't agree with having something like fetching from data storage from the view. I don't like it, but I guess it's the way it's supposed to be done. And it's going to be the most effective way to do it. So I don't know, maybe this year we get a new way of doing things, because I think, well, I haven't used core data for several years because the projects I've been working on are not using it. But I hope that we get some important improvements, like what SwiftUI was to UIKit. I would expect something to be the equivalent for core data.
And then we have a question from Casper. Thanks for sharing both. Would you recommend using Combine with UIKit components? I understand SwiftUI is handling observable object, observed object nicely, but for UIKit, it seems like we have to schedule a re-render on our own, and it looks like there's no way to know the changing context with object will change, which means we have to redraw everything on the screen, and it doesn't sound good in terms of performance. What are your thoughts on that, Tomas?
Let me reread again. Yeah, in that case, that's one of the problems that we are having in GoodNotes right now, which is actually having to compute the diffs ourselves. So if you try to follow an approach where you have a big state and you only modify parts, one part of it, you will have to be responsible for only re-rendering that small part of the object. In the other way, you will have to redraw the entire thing, and maybe you have only changed one field. So yeah, it does not sound good in terms of performance, but I think this is the best we can have right now.
Then there's one thing, like one tip for UI kit specifically. I would recommend to not use an observable object and subscribe to the object will change. Instead, this object will probably have published properties that indicate when something changed, and it's probably better to subscribe to those individually so you can update a label or whatever you need to update when that published property changes. I think that's what I would go for to prevent that whole diffing stuff. It's a little bit less fancy than SwiftUI, but you know, SwiftUI is the fancy new thing. So yeah, to me, that would be okay. Let's see. As far as I know, from Claudia, as far as I know, Combine creates strong references and we should handle it by ourselves as best practice. Do you know any other best practice thing that we should keep in mind when we use Combine? So regarding Combine creating strong references, that is a very interesting statement because it really just captures closures like any other thing that's not Combine would capture closures. So what happens, for example, if you have a data task publisher and you subscribe to it, then your closure will be captured. And by the time the publisher completes and there's no new values to be emitted, then the closure will also be released. So anytime you really have a publisher that you know will complete within reasonable time, you technically don't have to handle how self is captured because self will be released eventually and hopefully after a short time. However, if you don't know if a publisher will complete, then you need to weekly capture self because of, well, just how closure capture anywhere would work. So that's sort of for the strong, weak thing. Any other best practices? Well, store your cancellables. That is one that bites me more often than I will admit ever. If you have a publisher and you don't store your subscription, you don't store your cancelable, by the time the cancelable is deallocated, your whole subscription is deallocated unless you've strongly captured self, which means you would have 2 bugs in your code. So weak self when you are not entirely sure if the publisher will complete quickly, and capture your cancellables. And also don't go overboard as a sort of general thing. Like if you wouldn't call 20 functions in one function, then also don't chain 20 operators on a publisher and make little groups of things. What do you think about that, Tomas?
Yeah, I agree with your suggestions, and also, yes, try to keep things simple and composable, because I think the thing that I like the most about Combine is that it adds capabilities to compose things easily, things that we cannot compose easily with delegates, callbacks, or with asynchronous operations, suddenly become very, very composable with Combine. So try to keep things focused and yeah, narrow so that you can continue this composition.
Yeah. One for you from Colin. In my existing apps, I use the coordinator pattern, MVVM-C, to handle navigation within the app. Have you any experience or thoughts on using this design approach with SwiftUI?
I think it's perfectly fine. Yeah, in the end, you're abstracting over who makes the decisions to navigate through a certain place. In SwiftUI, you have to kind of explicitly say, like if you have a navigation link, you have to say which is the view, but you can still abstract over that, ask your coordinator to know where you're going to navigate. But other than that, I think it's okay. As I said, we still have to figure out a lot of things on what's the best way to use these new frameworks.
Yeah, definitely.
Yeah, things are changing a lot.
We have a question from Dominic. I feel like we've already kind of covered this, so I'm just going to read it. And unless you have anything interesting to add to what we've already said about it, we're just going to move on to the one after that. The question is, hi guys, firstly, thanks to the both of you. I would like to ask, what are your thoughts about using SwiftUI in production app? We already kind of talked about that. Is it ready now for complex apps? There's a lot of issues, and personally, one of the biggest problems is the routing mechanism. What are your thoughts about the current state of navigation, and do you have any advice? And I feel like we've been over that. It's a little bit messy. It's not very easy, not very straightforward. There's definitely a lot of ground to be covered there by Apple. Deepak with just a thank you. Another question from Dominic for you, Tomas. You mentioned composition architecture or Redux-like architectures. Is there any architecture you would definitely consider for more complex production apps? Would you go for unidirectional data flow architectures, considering the performance?
There is no silver bullet. So this is the answer, the short answer. The default for most applications, we were talking before the talk, most applications just limit to asking for some JSON data to an API, receiving it, doing some small processing, and rendering it to the UI. So for those, I think it's perfectly fine to have the composable architecture or any other Redux-like architectures. If you are going to do something more complex, then you need to carefully consider the needs that you have. For instance, we at GoodNotes, our application is much more complex than that. We have like high performance rendering for all the strokes that users are drawing on our notes. We have ink simulation. We have machine learning to detect handwriting. We have shape detection. So we have many, many different things. And we have adapted our architecture to fit those needs. So it's difficult to answer which architecture is best for your case. You have to consider what are the typical use cases that you have to implement. As I said, 90% of the applications are just fetching an API, and fetching data from an API and drawing it in the screen, maybe having some local cache where you store things just to avoid going too much to the network. For those, I think the composable architecture or any other similar architectures are going to work fine. They have put a lot of effort into measuring performance and making sure that everything is going fine. But I don't know the size of the applications that are now using those architectures. So again, it's something that we have to experiment a lot, measure, and adjust to our particular cases.
Yeah, definitely a nice, well-balanced discussion of that. Architecture is always tough.
Hey, Donny, sorry to interrupt. Just to let you both know, it's 10 minutes past 1, as I'm sure you can probably see. There is 20 minutes left on the Zoom, so it's entirely up to you guys if you wanted to stay on. Seems like you're enjoying it, so yeah.
I am in no rush to leave. I can take a few more questions. What about you,
Okay,
Tomas?
brilliant.
Yeah, maybe we can take 2 or 3 more.
Cool. Okay. So this one is not a question, but just a tip from Callum to Deepak about using a future if you're looking to eliminate promise kit as a dependency. Combine has a future publisher. Keep in mind, though, it is not a promise future. It's very different. And it also does not have the same affordances that you get with a promise. So it's a nice one-off thing, but it's not a one-on-one replacement. Just something to keep in mind. Let's see. UI testing, we've already covered. There's a question comparing SwiftUI to UIKit. I think we can answer that. At least my thoughts on that in one sentence is they're both messy. I don't know if you have deeper insight.
Yeah.
UI testing is really just a wrapper around your running app. So the architecture is really not a big deal in terms of.
As I said, I prefer using screenshot testing than doing that.
Yeah, for sure.
Trying to adapt my architecture so that I can simulate the events on the user interface.
For sure. Let's see. Let's combine one question from Joe Fredo. What are the most frustrating, confusing parts with Combine that you have to overcome and keep in mind? let's combine that with Bogo's question. Do you find error type restriction to be beneficial when comparing to RxSwift? It seems to have both pros and cons. Because I feel like the error part is one of the gotchas in Combine. So in Combine, every publisher has a type that it will emit, and it has a type of error that it can throw. So you cannot just have any random error pop up. It has to be specified on the publisher. So that's one of the gotchas that I would like to, say, like, study that, figure out how that works, how errors sort of move through your pipeline. And whether that's beneficial, I think it is, because it makes it very clear what you can expect on the error side. I do typically, for a more complicated pipeline, end up with just a generic Swift error. But still, I think it's good that you can specify the errors. Otherwise, functional reactive programming in general is a bit of a gotcha at first. Like, you have to really change how you think about dealing with asynchronous stuff. So the whole thing is kind of a gotcha that you have to sort of learn, like, hey, this is a publisher and I can map and flat map over it. But really focus on these basics. I've said map and flat map like a million times today, I think. And that's because those are the key parts that everything in Combine, I feel, is built on.
Yeah, definitely. I think, as I said before, having the compiler on your side helps you a lot, and having these possibilities to keep track of which errors are going to happen, it's also a great benefit. You know what to expect. If you just erase the error and go for the generic error protocol, then there is no point on having it as a parameter. Of course, you can do it because sometimes you don't care about which errors are going to happen, but I think it's beneficial for everyone to have that opportunity to have it there. This discussion has been going on in other functional programming communities and languages, and yeah, in the end, I think most of them are designing to adopt this error tracking as well.
Yeah. All right, one last question from Braden about unit testing when you're using Combine. I have some thoughts on it, but I'd like to hear your thoughts first, Tomas.
Which one is it?
It's the last message in chat. Have you had any issues unit testing when using Combine?
I haven't. So I don't know if you have had any.
No, me neither. I know that the Point Free guys have made a custom scheduler, so you can sort of forward time to sort of speed up your tests in some cases that are time sensitive. But generally speaking, the way I test Combine code, and RxSwift code too for that matter, is basically using Xcode's expectations if I want to keep things asynchronous, or I kind of just block the test, wait for the publisher to complete, and then do my assertions after.
Yeah, I guess the biggest challenge is always handling time. And as things in Combine are asynchronous and you may have delays and things like that, either having some sort of way of controlling time with a scheduler, or having a way to customize the delay times that you are offering, instead of setting up constant values, setting them up as variables that you can control from your testing, should make it work.
Yeah.
Brilliant. Thank you all so much, Donny and Tomas. That's an amazing Q&A session. I don't think it could have gone better. But yeah, really, really good to have you all here. And we will hopefully have an event in a couple more months. So yeah, all the best. Everyone enjoy their weekends. And yeah, just thanks again, Donny and Tomas.
Thank you, Harry.
Thanks for having us.
Thanks, everyone.
Thanks, everybody. Thank you.